I'm done. I'm done.
Okay, Ranim, so TIR is completed. I'll discuss the lens maker formula now. Lens maker formula in next learns in the next class. Okay.
Okay.
Okay. All right. Then. Okay. Bye. Yes, Oishi and Halima, is it audible?
Yes, ma'am.
All right. So we started just a minute. Okay, see. Now, coming to this chapter, alternating current. So we have first the basics of it. What's the difference between alternating current and a direct current? The direct current means the current is not changing with respect to, okay, like I is equal to 5 ampere or I is equal to 4 ampere. So this value is constantly fixed. For all values of the time, we will get the same amount of current. Okay, so same value of current is fixed. While if we talk about the alternating current, in alternating current, what will happen? The current will be continuously varying, okay, with respect to the time. Like initially, if the current starts, let's say from t is equal to 0, then the current moves at t is equal to 1 second to a different value. Then to this different value. Like this, the current continuously keeps on varying itself. This is known as alternating current because this is variable, while the direct current is fixed. This is the basic difference about. Now, what's an AC generator class? AC generator basically it's a device that converts the mechanical energy into the electrical energy. Mechanical energy into the electrical energy. Now, when we refer to mechanical energy class, we describe the kinetic energy, we describe the potential energy. So kinetic energy and potential energy, these are the mechanical energies which are related to movement, or you can say kinematics of the body. That is what is meant by kinetic and potential together. Means basically mechanical energy. In class 11th, you must have at least studied mechanical energy is conserved and all. So this is a part of it. When we say electrical energy, which kind of electricity? This is alternating current. Okay. Now, one thing that what on what basis do we have this? This is based on Faraday's law. Okay, Faraday's laws of EMI. So we know that E is equal to minus d phi over dt. Same principle as it is used by this AC generator class. Okay, it is based on the Faraday's laws of EMI that whenever the flux will change, magnetic field will change, flux will change, EMI will be used in the coil. So E is equal to minus d phi over dt. Now, in an AC dynamo, this says that magnetic, see, whatever is the rotation of the coil, no, there's a coil, I'll show you the construction of it. Whatever change is occurring due to the coil, due to the rotation of the coil, will eventually cause the um, magnetic field. Okay. So in an AC dynamo, magnetic flux gets changed due to rotation of coil in the uniform magnetic field. Like look how the AC this is constructed. This is the north polarity. This is the south polarity. This is the coil present. Now see, the coil keeps on turning itself at different angles to different values. This keeps on turning. Like if you have it kept straight, you know the concept of area vector. Area vector is made with the magnetic field. Now, when area vector is made with the magnetic field, see, if I say this is the coil, now here we'll have the area vector. Magnetic field's direction will be fixed. That is, let's say from north to the south. So what will happen when the coil will rotate? This angle will change. Let's say the coil has rotated further like this. Okay, this will further change. When it will move like this will change further. So that's why we say this theta is completely variable over here, and north and south polarity, these are completely required over here. Okay, so north to south, this is the magnetic field present, this is the coil. Now this coil rotates to different angles, and that different variations that are observed, that is what is fruitful to us and we are going to study. Now look, this is how it is constructed. Two magnets are present, one north polarity, other has the south polarity. Magnetic field goes from one to the other. In between, you have a coil. The coil is rotated, will be rotated by some angular velocity, that is omega. Okay, and this is placed on two slips, you can say, where which allows it to move basically. See, class, if you hold something which is rotating and you hold it onto something to make it rigid, so rotation will be slowed up. Okay, the rotation will be slowed up. So that's why what we do here in such concepts, wherever we have the magnetic field present, we allow the complete torque to occur, complete rotation to occur. So basically, the coil will be rotating. So you have north polarity, you have the south polarity, the magnetic field will be there, coil will be there, placed resting on the slips, armatures will be there, and this will be allowed to rotate. Okay, this much is there. See, now coming to the concept of flux. Flux is equal to phi is equal to BA cos theta, we know. Now, omega is the angular velocity. This is theta by t class. So what will theta be? Omega into t. So you can replace this theta with omega into t. Now see, E is equal to minus d phi over dt. So it means I can put this BA cos theta inside it, right? Are you getting this class? Yeah. So see, the number of turns are given. We'll multiply it with the number of turns as well. N BA cos theta. So E is equal to minus d phi over dt. Put in the value and BA cos omega t. Now let's differentiate it. This is differentiation, so let's differentiate it. Minus sign is already there. See, I think we haven't discussed this part before, that whenever you differentiate cos theta, cos omega t or something, when you are differentiating it over dt or anything. So what will happen here on differentiation? See, omega comes out and it gives you sine omega t inside with a negative sign. This is the rule. So remember it like a rule, class. So if that's the case, this will become the NBA omega, NBA will be taken out. Then we'll have into minus omega sine omega t. So what will it become? Minus into minus will be plus NBA omega sine omega t. That's the ER. Now, see class, if I have to take up its maximum value here, if I put the value of sine omega t as 1, means omega t will be pi by 2, or you can say 90 degree. So this we will have the maximum value of this, which is NBA omega. Now see, this is variable. EMF is also variable, just like the current. Maximum value that we get will be EMF, which will be plus NBA omega. And this will be negative minus NBA omega. Okay, so there are few one or two derivations that we'll discuss. Just do one thing. Till this part, just take the screenshots and the derivation, write it in your notebook.
Can you scroll? Up, ma'am.
Halima, this part? This is the derivation part. This you can copy. Okay, for the graph, you can take the screenshot. Okay, class. Now continuing with the AC cycle for a half cycle and a full cycle. So class, when I refer to half cycle or a full cycle, this means when the AC coil has covered only half of the turn. Like if in total it has completed only half of the turn, then we'll say this is full cycle, half cycle. And if it has completed the complete full revolution, we call it as full cycle. So current will be dq over dt. 0 is the initial time, t is the full time. So from here, if I shift dq and I write its value, it will be I into dt, integrating from 0 to t. Now, class, I is equal to I naught sine omega t. In AC current, the equation of current is I naught sine omega t. We put it here. Now, this is not t by 2, this is t. So when you put in here, look, when you are integrating sine theta, sine omega t, you will have minus cos omega t, and in integration, you will divide it by omega. Differentiation, what did we do? We used to multiply it outside. This here, it will be divided. Okay, so you multiply this here, you multiply this here. Look, I naught by omega, take it separate. 2 is equal to I naught by omega. Now minus cos C omega. First I'll put capital T minus cos 0 T. Now Q will be minus I naught by omega. This part will be cos 2 pi by T. See, omega can be written as 2 pi by T into T minus 1. See, cos 2 pi, that is also equal to 1. So class, basically 1 minus 1 is 0. So charge is coming 0. So if the charge is coming 0, it means the average current will also be 0. Current 0 means average EMF will be 0. It often comes prove that the average value over a full cycle for an AC generator is 0, like this for current and EMF. Okay. Do one thing, take the screenshot of this. For half cycle, I'll tell you that you copy. Just take the screenshot. Okay, class. See, let's write the same thing for the half cycle. So if I write this for a half cycle class, see, there will be some change here. First, this will become half cycle. Now, see, for a half cycle, you can't have the complete time t. This will be half of the time. See, this will be t by 2. This will be one more difference that will come, that the time will be. This is t by 2. This will also be t by 2. This will become t by 2. Now this will become t by 2. See class, 2 will be cancelled. It can't be 0 this time because cos pi is minus 1. We know this. So this is where the difference will come. This will be Q is equal to minus I naught omega. Cos pi is -1, that is -2. So charges minus I naught by omega into -2. So when you multiply both of these, charge will be given as I naught by omega. Let's write omega also as 2 pi by t. So 2 will be gone. Charge will be I naught t by pi. Now class, let's write the current. Current will be charge divided by time. Time is t by 2. 2 goes up. So 2 I naught t by pi and this t. So tt will be cancelled. I average becomes 2 I naught by pi, while E average comes to E naught pi. Okay, this you can write down this derivation. Half one you can write. Okay, is it clear till here? Oishi and Halima?
Yes, ma'am.
Okay. See, let's come to the next one, that is RMS current. So RMS current basically means that, see, you have RMS. R stands for root, M stands for mean, S stands for square. Now say the name is RMS, but order is first it is squared up, then the mean is taken, and then the root value. Like if I say current is there, so I naught square sine square omega t will be taken, means we squared it up. Second is to take the mean. Take the mean value of divided by total time. And finally is you put an under root. This is what IRMS is class. Now see here when we put it, we are solving this term first. At the end we'll divide it by capital T. Just the above part we are solving. Root and capital T we can put it later on. Okay, so see sine square omega t has an identity 1 minus cos 2 omega t by 2. So we put it over here. Now limits are from 0 to capital T. So put it. I RMS will be I naught square. This 2 will come out. This will be C1 minus cos omega. Means cos 2 omega. First we'll put the value, or we can do one thing. We can put the limits directly also after expanding one step. So here also you can put it. If I write, you can, if you want, you can put it like this. See, dt will be multiplied inside. No, let me multiply dt and write it in one step. Look here. This dt will be multiplied to this. This dt will be multiplied to this one. So this will be dt minus cos 2 omega t dt from 0 to capital T. Now capital T, this dt will be written as t I naught square by 2. Look, integral of dt will be written as t from 0 to t minus. This will be written as, see, 2 omega is constant. It will come in the denominator 2 omega. Cos 2 omega t dt. Oh, sorry, this will become sine. Cos becomes sine here. Again, this will also be from 0 to capital. So when you put in the value of t, this will be t minus 0. This will be t minus 0 if you put it here. This will be 4 pi by t because 2 into 2 pi, t minus 0. So let's put the limit here. I naught square 2 t1 minus 2 omega. This part is sine 4 pi capital T into capital T minus sine 0 degree. Now sine 0 is already 0 class. But sine 4 pi is also 0. So this term will be 0. Okay. So only I naught square into t by 2 will be left. So if that's the case, let's put it in IRMS. I naught t by 2 divided by t with an under root. Only these two things are missing. Capital T and the root. That will make it I naught by root 2. Similarly, for ERMS, you can calculate peak voltage by root 2. Let's see a question based on this. EMF is equal to 140 sine 300 t class. Equation that is given to us is this. So we know our original equation. If I make you relate it to the original equation that we have studied, this is E is equal to E naught sine omega t. Now, each and every term describes this, each value. Okay, so yes, Oishi, you tell me what's the peak value of the voltage? Yes, Oishi, look at the formula, look at the equation.
140.
140, very good. As it is, this will be 140. You don't even have to calculate anything in this. So first one will be, peak value will be 140. Second part, see, It's RMS value. Just now we studied a relation. E RMS is equal to E naught by root 2. It will be 140 by root 2. If you want, you can solve this further also. 140 by root 2. Root 2 can be written as 1.41, and that will give you 100 something, right? I am not writing this much. So then you have the third part. Third part says frequency of the supply. So Halima, do you know how to calculate the frequency? Yeah, Halima. Okay.
Well,
Any frequency is mentioned?
no, no.
Is there a mention of angular frequency?
300.
How much?
300.
Yes. Omega is equal to 300. So see, omega is equal to 2. I knew this is the relationship. Linear frequency will be 100 divided by 2 pi, which is equal to 150 by pi, this much of hertz. Okay, that completes with this big topic also. Question you can write, take the screenshot of this derivation. Then now we'll straight away come to the individual circuit then, right?
Now can you scroll up?
Okay, now let's start with phasors. Phasors class are basically rotating vectors. Rotating vectors means, see, current, voltages, these are actually not vectors, but just to represent it. Like, look, if I draw the potential here, and if I draw the current here, the gap between them is phase angle, and omega t will be the angle from the origin. Between the gap between them is known as the phase angle. In order to represent this, we have the concept of phasor and phasor diagrams. For a diagram that represents alternating current and alternating voltage of same frequency, okay, as the rotators with a proper phase angle between them. Let's say AC circuit only having resistor. R is the resistor, this is the AC. So E is equal to E naught sine omega t. Now use the Ohm's law, V is equal to IR. So this is E, so I can be calculated by just dividing it. E by R will give me I. E naught by R will give me I naught. I can write E naught by R as I naught, which is the peak value. So class, I am getting current as I naught sine omega t. E is equal to E naught sine omega t. Both current and EMF are in the same phase. There is no phase angle between them. See, this is the graph part, how to represent it graphically. See, you can observe here, the graphs are overlapping in terms of the angles. See, this is also starting from here, this is also starting from here. Yes, this can be varied, and this depends upon the case. Like in this case, it will be same in the instance case. Likewise, the current and EMF, they will also be like this in the same phase. If I talk about AC circuits only having resistors, so E is equal to E naught minus L di over dt we have. So you put the value of E as E naught sin omega t. Then we will shift L because I need only di over dt. Okay. From here, di can be written as minus E naught by L sin omega t dt. Again, sin theta. What did I tell you? This becomes cos theta divided by the constant. So cos, this will be omega t divided by minus cos omega t. No, this is a differentiation. No, yeah, we'll divide it by omega. Class. Sine integral of sine omega t will become minus cos omega t divided by omega. Now look class. Term omega is here. Now L I have written it together. Now let's bring this L out. So see, we'll get E naught by omega L, and cos theta can be written as sine 90 minus theta. So I've written it as sine 90 minus theta. Why have I written it? So that I get a uniform value. In terms of sine only I do not get cos. Because everything we are writing with respect to sine. So how will it will be easy, for us to determine which kind of angle and graph will be suitable. Now, omega L class is basically the resistance of this AC circuit having only inductor. Okay, this is basically the resistance that is here. So resistance means the way when you have a resistor, it is providing the resistance. What if I have a circuit having only inductor? It will also have charge. If charges are present class, then obviously resistance will be there. So that resistance of that particular circuit is known as omega L, which is known where L is known as the inductive reactance. Okay, so I can replace this as omega XL. Fine. So omega L will provide the resistance. That resistance is termed as XL, inductive reactance. Omega into L. XL is equal to omega L, which can be written as I naught. Now see, E is equal to E naught sin omega t plus phi. While current is minus omega t. Plus, what do you think? Which is leading, which is lagging by looking at the formula? Yes, class, look, E is equal to E naught sin omega t plus phi. I is equal to I naught sin omega t, 90 minus theta. So see, something is being subtracted from here. This will be lesser. So EMF leads, current lags. And I naught can be written as E naught by XL, IRMS can be written as ERMS by XL. Basically, just like your Ohm's law's obedience. So XL, when you expand it in terms of the linear frequency, it is 2 pi nu. So complete becomes 2 pi nu into L. Okay. 2 pi nu L is the formula that we'll be using. And if you plot a graph between this, you will obtain a straight line. XL is directly proportional to the frequency. So see, if voltage is ahead, look, voltage is having 90-degree, current is only at 0. So there is a gap of 90-degree. You can see phase difference is pi by 2. And similarly, if you have to show it on the phasor, see, I have shown that EMF is leading, current is still behind. So this is the significance of this graphs and the phasors basically. Now, one thing, tell me, Oishi and Halima, have you understood these two first? These two graphs and everything?
Yes,
Eh,
ma'am.
Okay, then. Then we have AC circuit having only a capacitor. So derivations you should write. Rest of the thing you can take the screenshot. Just take the screenshot. Just write the derivations. Okay, see this part you can take the screenshot because one more is there, otherwise it won't be completed. This you can take the screenshot. Okay, see class now AC circuit having only capacitor. So see we use the equation Q is equal to CB. And for the potential, we know we have E is equal to E naught sine omega t. So that's what we'll use. Okay, so I is equal to dq over dt. So we differentiate this. See this part is C into V. So when you differentiate this, C E naught will come out. D sine theta. See when you differentiate sine theta, you get a cos theta and you multiply it with omega. So it will be E naught into C omega into cos omega t. Now look class, E C omega, E is divided by C omega, they are different. So what we do, we shift this in denominator's denominator. Now when it goes up, it will become back to this. That's why we have written E naught by 1 by omega C. Look class here, 1 by omega C is the constant this time, that is capacitive reactance. And here current leads. Look, in the current equation, we are getting plus sign. So xc is equal to 1 by omega c, or you can say 2 pi nu c. And see, since the frequency is inversely proportional, the graph will be a hyperbolic graph. And if you plot the phasor diagram, look, even EMF has started, current is already covering 90 degree. So just the reverse of it, and see, current is leading by 90 degree. These were the individual circuits. Now, a few topics are there. Major part was done in today's class. One topic is there that is also very important and constitutes a major portion of it. That is resolution of vectors. Okay, not resolution, sorry. Resonance of the phasors. Resonance basically. And apart from resonance, LCR circuit, resonance, Q factor, this is one single big topic. After that, we won't have much. Power, energy, and transformer will need one class. So one class, two classes will complete this. One or two more classes that will complete this. Okay, this is hyperbolic, the phasors. All right, class, just take the screenshot of this. Okay, class, I'll stop here. Now, resonance LCR, we'll do it in the next class, and one more class for power and transformers. Okay. All right. Then. Thank you.
Thank you. Thank you.